We'll prove this problem in two different ways. First, by direct proof, and for that we're going to use modus ponens a couple times. And after that we'll redo it by proving the contrapositive, and for that we'll use modus ponens once and then modus tollens after that. Here's the problem. Suppose A is a subset of C and B and C are disjoint. Prove that if X is in A, then X is not in B. So let's try and draw a picture of that situation. Here is the set A, and that's a subset of another set, C. And we're assuming that B and C are disjoint, so they don't have any overlap. So maybe B is over here somewhere. And we're supposed to prove that if X is in A, then it's not in B. Okay, and that seems clear from the picture. And if it's in A, then it's also in C, and therefore it can't be in B. And we can think about the contrapositive as well. If X is in B, then X is not in A, right? If X is over here in B, then it can't be in C because B and C are disjoint, and therefore it can't be in A either because A is a subset of C. Okay, so that's the intuition. Let's try and write down the logic. We've got two givens and a goal. And for our goal, let's use direct proof first. And so we'll bring our antecedent X in A over as a given, and our new goal is X not in B. And then I have a couple statements up here which has some sort of mathematical terminology or a symbol in them. And we need to write those out in logical notation to be able to use them. And so this one, A is a subset of C, can be written as well, X in A implies X in C. Really there should be a for all X quantifier in the beginning here, but we're going to talk about quantifiers and proofs in a future section, so we'll just leave it like this for now. And those two statements together give us modus ponens, right? We can conclude that X is in C. And now B and C are disjoint has a couple different definitions. The one I want to use here is that if X is in C, then X is not in B, right? Because it can't be in both. Because now I have another modus ponens right here, from which I conclude that X is not in B, which is my goal. So let's try to write out this proof. The first thing we did was direct proof, moving the antecedent over as a given. So I'll say, suppose X is in A. We show that X is not in B. And then we combine these two statements, right? And by modus ponens, we are able to conclude that X is in C. Okay. And this conditional here actually came from, that was the definition of A being a subset of C. Okay. So in my proof, I'd rather put this sort of mathematical statement than its logical equivalent. It'll just be easier for the reader to digest. All right. It's better style. So what I'll say is because X is in A, and because A is a subset of C, it follows that X is, it is in C. Okay, so that's by the definition of subset and modus ponens. And then after that, all that's left is another modus ponens from here over to our goal. And this conditional statement, that was the definition of B and C being disjoint. So this time I will say because X is in C and B and C are disjoint, it follows that X is not in B, okay, by the definition of disjoint and modus ponens. And we're done with that direct proof. Now let's try to prove the same statement by proving the contrapositive. We have the same givens and goal. This time we're going to take the negation of the consequent, and that gives us a new given X in B, And the negation of the antecedent gives us a goal, x not in A. And we have the definition of A being a subset of C, and a definition of B and C being disjoint. And this time I'm going to use the opposite of the definition I used up here, and use that x in B implies x not in C. And the reason is because now I can combine that with my given x in B, and modus ponens gives me that x is not in C. And so I am here, and here's a case of modus tollens, right? We have a conditional, and we know that the negation of the consequent is true, and from that we can conclude the negation of the antecedent, namely x not in A, which was our goal. So let's write this one up. We're proving the contrapositive, so we took the negation of the consequent as a given. So I'll say we prove the contrapositive. Suppose x is in B. We show that x is not in A. All right. And then the next step was to use modus ponens on these two to conclude that x is not in C. And this conditional here was the definition of B and C being disjoint. All right, so I'll say because x is in B and B and C are disjoint, it follows that x is not in C by the definition of disjoint and modus ponens. And finally we did modus tollens to go from these two to our goal, that x is not in A. So I'll say because x is not in C, and this conditional was just the definition of A being a subset of C, so A subset of C, it follows that x is not in A. And that's by a definition of subset and modus tollens. And that finishes it up.